In today's rapidly evolving digital landscape, businesses are increasingly turning to the cloud to enhance their flexibility, scalability, and cost efficiency. The cloud offers a dynamic environment where resources can be allocated and reallocated as needed, providing businesses with the agility to respond to changing market demands and opportunities. One of the most significant trends in cloud computing is the adoption of a multi-cloud strategy. Multi-cloud, the practice of using multiple cloud providers, has emerged as a popular choice among organizations. This approach offers a plethora of benefits, including increased redundancy, flexibility, and the ability to leverage the unique strengths of different cloud platforms. By leveraging the strengths of different providers, organizations can avoid vendor lock-in, optimize costs, and enhance application resilience. This means that businesses are not tied to a single provider's ecosystem, allowing them to choose the best services and solutions for their specific needs. Additionally, cost optimization becomes more achievable as companies can select the most cost-effective options from various providers. Imagine a scenario where a company relies solely on a single cloud provider for all its IT needs. While this might seem convenient, it also introduces significant risks. The company becomes heavily dependent on the reliability and performance of that one provider, with no alternatives if issues arise. Suddenly, the provider experiences a major outage, bringing the company's operations to a grinding halt. This can lead to significant financial losses, damage to the company's reputation, and a loss of customer trust. The impact of such an outage can be far-reaching, affecting not just the immediate operations but also long-term business prospects. This situation highlights the risk of relying on a single point of failure. In a world where uptime and reliability are critical, having all your eggs in one basket can be a dangerous strategy. Diversifying across multiple providers can mitigate this risk. Multi-cloud mitigates this risk by distributing workloads across multiple providers, ensuring business continuity even if one provider experiences downtime. This approach not only enhances reliability, but also provides a safety net that can keep critical applications and services running smoothly. Furthermore, different cloud providers excel in different areas. Some may offer superior compute capabilities, while others might provide more robust storage solutions or advanced machine learning tools. By adopting a multi-cloud approach, organizations can take advantage of the best-of-breed services from each provider. One provider might offer superior compute capabilities, while another might have a more robust storage solution. This allows businesses to tailor their cloud strategy to their specific needs, ensuring they get the best performance and value from their cloud investments. By adopting a multi-cloud approach, organizations can select the best-of-breed services from each provider, optimizing their IT infrastructure for performance and cost effectiveness. This strategic flexibility enables businesses to stay competitive and innovative in a fast-paced digital world. However, this flexibility comes at a price: increased complexity. Managing multiple cloud environments, each with its own set of tools, APIs, and management consoles, can quickly become overwhelming. The need to integrate and manage these diverse environments requires significant expertise and resources. Managing multiple cloud environments, each with its own set of tools, APIs, and management consoles, can quickly become overwhelming. The complexity of coordinating between different platforms, ensuring compatibility, and maintaining security across all environments can be daunting. The following sections delve into the technical complexities of multi-cloud environments and explore strategies to mitigate these challenges. We will discuss best practices for managing multi-cloud deployments, tools that can simplify operations, and how to build a resilient and efficient multi-cloud strategy that aligns with your business goals. One of the primary challenges of managing multi-cloud environments stems from the lack of standardization across cloud providers. This lack of uniformity can be a significant roadblock for organizations trying to leverage the full potential of multi-cloud strategies. Each cloud provider has its own unique set of tools, APIs, and management consoles, which can vary greatly in terms of functionality, design, and user experience. Each provider offers its own set of tools, APIs, and management consoles, often with significant variations in functionality and design. For instance, what might be a straightforward task in one cloud environment could be a complex and convoluted process in another. This disparity forces IT teams to become proficient in multiple systems, each with its own learning curve and idiosyncrasies. This inconsistency creates a significant hurdle for IT teams tasked with managing and orchestrating workloads across multiple clouds. The lack of a standardized approach means that IT professionals must constantly switch contexts, which can lead to errors and inefficiencies. The mental load of juggling different interfaces and tools can be overwhelming, especially when under pressure to maintain uptime and performance. Imagine trying to assemble a complex jigsaw puzzle, where each piece comes from a different puzzle set. The pieces might share some similarities, but their shapes and sizes are subtly different, making it incredibly challenging to fit them together. This analogy perfectly captures the frustration of dealing with inconsistent APIs and tools in a multi-cloud environment. The pieces might share some similarities, but their shapes and sizes are subtly different, making it incredibly challenging to fit them together. This analogy perfectly captures the frustration of dealing with inconsistent APIs and tools in a multi-cloud environment. The lack of standardization not only complicates the integration process, but also increases the likelihood of errors and misconfigurations. This analogy perfectly captures the frustration of dealing with inconsistent APIs and tools in a multi-cloud environment. Developers accustomed to one provider's API must invest significant time and effort to learn and adapt to the nuances of another provider's API. This learning curve increases operational overhead and slows down development cycles. The time spent on learning and adapting could be better utilized in developing and deploying new features and services. Developers accustomed to one provider's API must invest significant time and effort to learn and adapt to the nuances of another provider's API. This learning curve increases operational overhead and slows down development cycles. Moreover, the constant need to switch between different coding environments and tools can lead to a fragmented workflow, further reducing productivity. This learning curve increases operational overhead and slows down development cycles. Moreover, integrating applications and services across different clouds becomes a complex undertaking, as developers must bridge the gaps between disparate APIs. The lack of a unified approach can lead to integration issues, making it difficult to ensure seamless communication between different cloud services. Moreover, integrating applications and services across different clouds becomes a complex undertaking, as developers must bridge the gaps between disparate APIs. The lack of a unified approach can lead to integration issues, making it difficult to ensure seamless communication between different cloud services. This complexity can slow down the deployment of new applications and services, impacting the overall agility of the organization. To address this challenge, organizations can adopt API management platforms that provide a unified interface for interacting with different cloud APIs. These platforms abstract away the complexities of individual APIs, allowing developers to interact with different clouds using a consistent set of tools and commands. This not only simplifies the development process, but also reduces the risk of errors and misconfigurations. These platforms abstract away the complexities of individual APIs, allowing developers to interact with different clouds using a consistent set of tools and commands. By providing a unified interface, these platforms enable organizations to streamline their multi-cloud operations, improve efficiency, and accelerate the deployment of new applications and services. This approach not only enhances productivity but also allows IT teams to focus on more strategic initiatives, driving innovation and growth. Networking is another area where multi-cloud environments introduce significant complexity. Connecting different cloud environments securely and efficiently requires careful planning and a deep understanding of networking concepts. Organizations must establish reliable and high-performance connections between their on-premises infrastructure and multiple cloud providers, ensuring seamless data flow and application performance. Imagine trying to connect multiple islands with bridges, each bridge representing a network connection between different cloud environments or on-premises data centers. The challenge lies in designing and building these bridges to handle the volume of traffic, ensure secure communication, and maintain optimal performance. Latency, the delay in data transmission, becomes a critical consideration in multi-cloud environments. Applications distributed across multiple geographically dispersed cloud regions can suffer from performance degradation if network latency is not carefully managed. To mitigate network complexity, organizations can leverage software-defined networking solutions. SDN provides a centralized control plane for managing and orchestrating network resources across multiple clouds, simplifying network management and enhancing agility. Data management and security present significant challenges in multi-cloud environments. As organizations increasingly adopt multi-cloud strategies, they face the daunting task of managing and securing information across various cloud platforms. Each cloud provider has its own set of tools, protocols, and security measures, making it difficult to maintain a consistent approach to data management and security. Maintaining data consistency, ensuring data security, and complying with data privacy regulations become increasingly complex when data is distributed across multiple cloud providers. Each provider may have different compliance requirements, and organizations must navigate these to avoid potential legal and financial repercussions. This complexity necessitates a robust strategy to manage data across these diverse environments. Imagine trying to keep track of a fleet of ships sailing across multiple oceans, each ship representing a piece of data stored in a different cloud. Just as each ship must navigate different waters and comply with various maritime laws, each piece of data must adhere to the specific regulations and security protocols of its respective cloud environment. This analogy highlights the complexity and the need for meticulous management. The challenge lies in knowing where each ship is at any given time, ensuring the safety of the cargo, and complying with the maritime laws of different countries. Similarly, organizations must have real-time visibility into where their data resides, ensure its security, and comply with the data privacy laws of different jurisdictions. This requires sophisticated tracking and monitoring tools. Data synchronization becomes a major concern, as changes made to data in one cloud must be reflected in other clouds to maintain data integrity. Without proper synchronization, data discrepancies can occur, leading to potential errors and inconsistencies. This is particularly critical for applications that rely on real-time data updates. Moreover, securing data across multiple cloud providers requires a comprehensive security strategy that encompasses data encryption, access control, and threat detection mechanisms. Each cloud provider may offer different security features, and organizations must ensure that their security policies are consistently applied across all environments. This includes regular security audits and updates to address emerging threats. Organizations can address these challenges by implementing data governance policies that define data handling procedures across all cloud environments. These policies should outline how data is stored, accessed, and shared, ensuring that all cloud providers adhere to the same standards. Effective data governance also involves training employees on best practices and regularly reviewing and updating policies. Centralized data management platforms can simplify data integration, synchronization, and security monitoring, providing a unified view of data across multiple clouds. These platforms enable organizations to manage their data more efficiently, reduce the risk of data breaches, and ensure compliance with regulatory requirements. By leveraging such tools, organizations can achieve greater control and visibility over their multi-cloud environments, ultimately enhancing their overall data management and security posture.